Hello, STT 315. This is recitation 10. So question 1. Refer to the Business and Society study on the sustainability behaviors of CPA corporations. Corporate sustainability, refers to business practices designed around social and environmental considerations. The level of support senior managers has for corporate sustainability was measured quantitatively on a scale ranging from 0 to 160 points. The study provided the following information on the distribution of levels of support for sustainability. Mu equals 68, sigma equals 27. Now consider a random sample of 45 senior managers and let X represent the sample mean level of support. A, give the value of mu X bar, the mean of the sampling distribution of X bar, and interpret the results. So here we have that the mean or the expectation of X bar is 68, and this is given here. And then give the value of S of X bar, the standard deviation of the sampling distribution of X, and interpret the results. So here we'll have S of X bar equals sigma divided by the square root of N. So sigma equals 27, which that was given right here. And then we're given that the sample size is 45 senior managers. So we have 27 divided by the square root of 45, and that's 4.0249. What does the central limit theorem say about the shape of the sampling distribution of X bar? So we have that X bar follows a normal distribution with mean mu and standard deviation S. So we have, if I just wanted to visualize it, we have this bell-shaped curve, which is the normal distribution, and our mean is around 68, which is where the highest part of the curve is, and then we'll be using the rest of that for part D. So now we want to find the probability that X bar is greater than 65. So we're going to use the normal CDF function in our calculator. So to visualize that, 65 would be somewhere to the left of 68. So we're interested in X bar greater than 65. So our lower bound here is going to be 65, and our upper bound is going to be infinity, because we want the area under the curve from 65 to infinity. And then we have the mean is 68, and the standard deviation is 4.0249, or 27 divided by the square root of 45. So when you put that in your calculator, you get 0.77197. So that is the area under the curve. So that's the question mark. Question 2. Geotechnical engineers use water level manometer surveys to assess the levelness of newly constructed concrete slabs. Elevations are typically measured at 8 points on the slab. Of interest is the maximum differential between elevations. The journal Performance of Constructed Facilities published an article on the levelness of slabs in California residential developments. Elevation data collected for more than 1,300 concrete slabs before tensioning revealed that maximum differential X has a mean of mu equal 0.53 inch and a standard deviation of sigma equal 0.193 inch. Consider a sample of n equal 50 slabs selected from the surveyed and let X represent the mean of the sample. Fully describe the sampling distribution of X. So here we're interested in the mean of the sample. So the expectation of X bar equals mu, and that's 0.53. That's given right here. And then the standard deviation of this should be X bar, not just X. So this should be a bar over the X. So S of X bar equals sigma over the square root of N. So here we have 0.193 inches. So that's sigma divided by, and then we have our sample size of 50 slabs. So divided by the square root of 50, and we get 0.027294. And if we were to draw what the distribution looks like, so we have a normal distribution where the mean is the curve is centered around the mean of 0.53. Now we want to find the probability that X bar is greater than 0.58. So 0.58 is somewhere to the right of 0.53 because it's greater than 0.53. So we're interested in the area under the curve from 0.58 to infinity. So here we're going to use normal CDF. 0.58 is our lower bound. Infinity, or 10 to the 10, is our upper bound. And then we have our mean of 0.53 and our standard deviation of 0.193 divided by the square root of 50. So when you put that in your calculator, you get 0.0335. So that is the area under the curve for the shaded region. Question 3. Refer to the American Economic Review study of college dropouts. Recall that one factor thought to influence the college dropout decision was expected GPA for a student who studied 3 hours per day. In a representative sample of 307 college students who studied 3 hours per day, the mean GPA was X bar equal to 3.11, and the standard deviation was S equal to 0.66. Of interest is mu, the true mean GPA of all college students who study 3 hours per day. Give a point estimate for mu. So we don't know mu, but it's of interest. So a good point estimate for mu is X bar. So we have X bar equal 3.11. Part B, give an interval estimate for mu. Use a confidence coefficient of 0.98. So here we are going to use Q norm of 1 plus alpha divided by 2. So that gives us our Z alpha over 2. So that in this problem equals 1 plus 0.98 divided by 2, which equals 0.99. So here we're going to use the Z interval on the TI-84 calculator. And so you should get 3.0224 is the lower bound of the confidence interval, and then 3.1976 is the upper bound. And I have a TI Inspire calculator. So how you would do this on that calculator is first you would select menu, and then you would choose option 6, which is statistics, then option 6 again, which is confidence intervals, then option 1, and you would choose Z interval, and then data input method would be stats, and then you would hit OK, and then you would enter your info. So here sigma equals 0.66, which was given. Our X bar equals 3.11, which was also given, and then our N is 307, which is also given right here. It's highlighted in yellow. And then our confidence level is 0.98. So question 4, recall that, I'm just going to say mock, describes negative character traits that include manipulation, cunning, duplicity, deception, and bad faith. A mock rating score was determined for each in a sample of accounting alumni of a large Southwestern university. Scores range from a low of 40 and a high of 60, with the theoretical neutral mock rating score of 100. The 122 purchasing managers in a sample had a mean mock rating score of 99.6 with a standard deviation of 12.6. From the sample estimate, the true mean mock rating score of all purchasing managers. So here we have, oh, sorry, it says estimate the true mean. So a good estimate for the true mean would be X bar. So that's given as 99.6 right here. And then form a 95% confidence interval for that estimate. So we're going to use the Z interval on the calculator. And so you're going to input your information here. So you would have your sigma equals 12.6, which is right here. That's the standard deviation. Then you have X bar equals 99.6. And then N equals 122, which is right here. We have 122 purchasing managers. And our confidence level is 0.95. So you put that in the calculator and you should get your confidence interval lower bound is 97.364 and the upper bound of the confidence interval as 101.84. Next is question 5. Sorry, it's a little bit hard to read. When planning for a new forest road to be used for tree harvesting, planners must select the location to minimize tractor skidding distance. In the Journal of Forest Engineering, researchers wanted to estimate the true mean skidding distance along a new road in a European forest. The skidding distances in meters were measured at 20 randomly selected road sites. These values are given in the accompanying table. So the accompanying table is all the way on this page. So this is the table and we have 20 random selected road sites. So there's 20 different values here. So there's one value per road site. Now we have part A, estimate the true mean skidding distance for the road with a 95% confidence interval. So here we're going to use a T interval because our sample size is 20 and the book says that, you know, if it's less than 30, then you're dealing with like a smaller sample. So you would use the T interval when you have a small sample. And then we have our X bar, you're going to calculate, and S, you're going to calculate from the values given. So you're going to take the mean of all of these numbers, and there's 20 of them. So when you take the mean, you should get 358.45. And then the standard deviation of all the numbers in the table is 117.8172. So then you're going to use your calculator to calculate the confidence interval. So before I showed on the TI Inspire calculator how to input it, but instead of choosing Z interval, now you're going to choose option 2 for T interval if you have a TI Inspire. So now, so when you put that into your calculator, you should get the lower bound for the 95% confidence interval is 303.31 and the upper bound is 413.59. Give a practical interpretation of the interval in part A. So 95, so notice it's a 95% confidence interval. So 95% of the intervals from random sampling will contain the true mean. And then what conditions are required for the inference part B to be valid? Are these conditions reasonably satisfied? So we have that a random sample is selected from the target population and the relative frequency of a population is approximately normal, and those are reasonably satisfied. Next is question 6. IPOs, initial public offerings of stock, create billions of dollars of new wealth for owners, managers, and employees of companies that were previously privately owned. Nevertheless, hundreds of large and thousands of small companies remain privately owned. The revenues of a random sample of 15 firms from Forbes' 216 largest private companies list are given in the table below. So here we have the different companies, and then we have the revenue in the right-hand column, and note that the revenue is in billions. So this was 12.4 billion. and so on and so forth. Part A, describe the population from which the random sample was drawn. So here the population is Forbes 216 largest private companies. So the random sample is 15 firms from the Forbes largest companies, 216. So this is the population here. So Forbes 216 largest private company. And then use a 98% confidence interval to estimate the mean revenue of the population of companies in this question. So here we're going to use T interval again because we have 15 firms, which is less than 30. And then our X bar is, you're going to add up all of these and then divide it by 15 to get the X bar of 20.933. And then the standard deviation of X bar is 51.4311. And our confidence level is 98%. And then we're going to choose T interval in our calculator. So that gives us the interval of negative 13.92 to 55.785. Interpret your confidence interval for the context of the profit. So here we have that profit loss is in the interval above because we have some negative values contained in that interval. What characteristic must the population possess to ensure the appropriateness of the estimation procedure used in Part B? So that the relative frequency of the population is approximately normal. And Part E, suppose Forbes reports that the true mean revenue of 216 companies on the list is 5 billion. Is that claim believable? So first I would go to that confidence interval and see is 5 billion in here. And remember, we're in the billion. So this is 13.92 billion or negative 13.92 billion to 55.785 billion. So here 5 billion is in the interval. So it is believable. Okay. Recall that you used a 99% confidence interval to estimate the proportion of all social robots designed with legs but no wheels. How many social robots would you need to be sampled in order to estimate the proportion to within 0.075 of its true value? So here we have, so we want to know how many social robots would be needed. So N is greater than or equal to K squared times P times 1 minus P divided by M squared. So our M is 0.0752 and our K is the inverse norm of 1.99 divided by 2, which is 2.576. So we have our K, we have our M, and then we're going to use our P equal to 0.5 because that would be the worst case. So when you plug that into this expression above, you get, so K squared, which is 2.576 squared times 0.5, and then 1 minus P. So 1 minus 0.5 is also 0.5. So we have 0.5 times 0.5 divided by M squared, which is 0.0752 squared. So when you plug that in to your calculator, you get 293.35, but we don't want to have a fraction of whatever a social robot is. So our N is going to be 294. Okay, now we're going to go over the homework that was due this week. So a multiple choice exam consists of 10 questions. Questions 1 through 5 have alternatives for each question, and questions 6 through 10 have 7 alternatives for each question. A student chooses an answer at random for each question. X is the number of correct choices made by the student for questions 1 through 5. Y is the number of correct choices made by the students for questions 6 through 10. So here I just color coded that my X's are the yellow highlight and my Y is anything associated with Y is the blue. And then Z is the number of correct choices made by the student. So here we have Z equals X plus Y. So which we want to choose the option that is correct. So here we have that X and Y are binomial, but Z is not. So because remember that Z is X plus Y. So even though X and Y are binomial, when you add two binomials, you don't necessarily, you get a binomial. So you have X and Y are binomial, but Z is not. X is a binomial random variable with n equal to 10 and p equal to 0.4. Use the binomial table or Excel to find the numerical values of the following quantities. So I'm going to use the binomial table that's in the book. So we're going to be first interested in the probability that X is less than or equal to 3. So if I look here, this is scanned from the book. So here I'm choosing the table where n equals 10. And let me go back up. N equals 10 and p equals 0.4. Okay, so here I have n equals 10 and p equals 0.4, which is this column here. And so I'm interested in the probability that X is less than or equal to 3. So each value here is taken by adding like the previous values. So that's why the probability of X less than 3 is just 0.382. So that's this value here. Okay, now we want to find the probability that X equals 3. So we can't just use 0.382 anymore because this takes into account adding when k equals 0, 1, 2, and 3. So if we just want the probability where k equals 3 alone, then we're going to take 0.382 and subtract 0.167 to get the answer, because this is when the probability of k equals 0 plus the probability that k equals 1 plus the probability that k equals 2. So when you do 0.382 and subtract 0.167, you get just the probability where X equals 3 or k. So the table that I'm using, you can think of this, your X as k. So here we have, so when you do 0.382 minus 0.167, you get 0.215. And now we want the probability that X is greater than or equal to 0.3. So we're going to do, so on the table, you can think of it as, starting at 3 and then greater than that. So we have 1 minus the probability that X is less than or equal to 3 plus the probability of X equal to 3. So I'm using the rule where the probability of event A equals 1 minus the probability of A complement. So here we have the probability of X greater than or equal to 3 is the probability that X is strictly less than 3 is essentially what I'm doing. But I don't have the probability where X is strictly less than 3. So what I'm going to do is subtract the probability that X is less than or equal to 3. But then I'm going to add back in the probability that X equals 3. So when you do that, so this is from the second part of the question, this is from the first part of the question. So when you compute that, you get 0.833 as the answer. Records of a health insurance company shows that 40% of its policyholders submit a claim during the year. If 20 policyholders are selected at random with replacement, what is the probability that 2 or fewer will submit a claim in the coming year? So here we have we're dealing with a binomial random variable, and n equals 20. And because we have 20 policyholders, and p equals 0.4, that's given here, that's 40%. So we want to find the probability that x is less than or equal to 2, because what is the probability that 2 or fewer will submit a claim? So you can either do p binomial function in R, and that would be, you would enter in 2, because that's here, and then 20 is sample size, and 0.4 is p to get 0.004, or you could use your calculator and use the binomial CDF function, and then you input the same values but just in a different order. So you would input first the sample size, then p, and then your x. What is the expected number of policyholders among the 20 selected who will submit a claim? So here it's just asking what is the expectation of x. So that equals n times p. So n equals 20 and p equals 0.4. So when you multiply those together, you get 8. What is the standard deviation of the number of policyholders among the 20 selected who will submit a claim? So here 20 is our sample size, and we're going to do this square root of np times 1 minus p. So 20 is our sample size, 0.4 is our p, and then 1 minus 0.4 is 0.6. So when you compute that, you get 2.191. Accidents occur along a 3-mile stretch of highway at an average of 1.5 a month. What is the Poisson probability that there will be exactly one accident next month? So here, our lambda is 1.5. So for a Poisson, we have the probability of x equal to k equals e to the negative lambda times lambda to the k divided by k factorial. So we can just plug in what we have. So the probability that x equals 1, because we want to know what is the Poisson probability that there will be exactly one accident. So that would be the probability that x equals 1, because we want to know for one accident. So that equals e to the negative 1.5, because lambda is 1.5. And then 1.5, and then this should be 1 as the exponent, which is 1.5. But our k is 1, and then we have k factorial on the denominator, so that's 1 factorial, which is also 1. So when you plug this into your calculator, you get 0.335. Or you could use R and use dpoise. This should be a S. dpois, and then 1 is our x or k, and then 1.5 is our lambda. And that will also give you 0.335. X is a normal random variable with mean 90. Y is a normal random variable with mean 100. If x and y have the same standard deviation, then, so here the correct answer would be that the probability of x, the probability that x is within 1 standard deviation of its mean is the same as the probability that y is within 1 standard deviation of its mean. So this is true because here, even though x has a smaller mean than y, this will be true for any random variable, where that the probability that x is within 1 standard deviation is the same of its mean is the same as the probability of y that is within 1 standard deviation of its mean. So this is kind of like a tricky question, but where they try to trick you by giving you different means, but yes, this won't change. So these are the two above it are incorrect. So we wouldn't have that the probability of X is within 1 standard deviation of its mean is larger than the probability that Y is within 1 standard deviation, or vice versa, smaller. It's the same. Okay. X is a normal random variable with mean mu X and standard deviation sigma X. Y is a normal random variable with mean mu Y and standard deviation sigma Y. If the standard deviation of X is smaller than Y, then, and so this, they're trying to trick you again, but the correct answer is that the proportion of X within 1 standard deviation of its mean is the same as the proportion of Y that is within 1 standard deviation of its mean. Okay. Z is a standard normal random variable. So we want to find the probability that Z is in between 0 and 1, but not including 0 and 1. So we're going to use the normal CDF function in our calculator. And so our lower bound is 0, our upper bound is 1, and then we're in a standard normal variable. So for standard normal, the mean is 0 and the standard deviation is 1. So when you put that in your calculator, you should get 0.341. If Z is a standard normal random variable, then the probability that Z is in negative 0.6 to 0.6 is, so we're going to use normal CDF again, and our mean and our standard deviation is going to stay the same. So our mean is 0, our standard deviation is 1, but now our lower bound is negative 0.6 and our upper bound is positive 0.6. So when you put that in your calculator, you should get 0.451. If Z is a standard normal random variable, then the probability that Z is greater than 0.5 is, so here we have the normal CDF function again, and our lower bound is 0.5 and our upper bound is infinity. So for infinity, we have 10 to the 10, and then our mean and our standard deviation is still 0 and 1 because it's a standard normal variable. So we have 0.309 as the answer. The value of A such that the probability of negative A less than Z less than A equals 0.76 is, so here we're dealing with a normal, standard normal variable because here we have Z. So I know that, okay, Z means standard normal, so that means mean 0, standard deviation 1 again. So what the question is asking is, so we're given that, so let's say this is our standard normal curve that's centered around 0, which is our mean, and then we have negative A somewhere on the left and positive A somewhere on the right. So A or some number A, we're going to need to find what that number is, and we're given that this area under the curve from negative A to A is 0.76. So that's what this is saying here. So in order to find what this value is and what this value is, we're going to use the inverse norm function. But before we do that, we have to, because the inverse norm function works from left to right on the number line on the x-axis, we need to find what this area is under the curve. Then we can input that into our inverse norm function to get what negative A is, and then we know, okay, we know what negative A is, then we also know what positive A is. So that's the method that I used. So here, the area under the left part of like this left blue value and this right blue value is going to be the same because it's symmetrical and we're centered, you know, around 0. So here we have 1, which 1 is the total area under the curve. So 1 minus 0.76 equals 0.24. So I know, okay, 0.24 is the area of this left side and right side, but now I'm just interested in this, you know, in each individual side. So I'm going to do 0.24 divided by 2. So that gives us 0.12. So there's a 0.12 here and a 0.12 here. So when you add all of this together as a check, you should get 1. So 0.12 plus 0.76 plus 0.12 equals 1. So now we're finally ready to use the inverse norm function on our calculator. So, going from left to right, our area up to negative a is 0.12. So we have 0.12 and then our mean is 0 and our standard deviation is 1 because we're in a standard normal variable. So this gives us the negative a, which is negative 1.175. So that's this value. So our a is positive 1.75. You could also do the area inverse norm function and use the area of 0.12 plus 0.76. Excuse me. And then the same mean and standard deviation. And then that will just give you positive a. Okay. Next is the social insight test. Evaluates how accurately the subject appraises other people. In the reference population used to develop the test scores are approximately normal with mean 21.4 and standard deviation 4.8. What proportion of the population has scores below 15.64? Round the answer to 2 decimal places. So it's asking what is the probability that x is less than 15.64? So here we have that test scores are approximately normal. So we have this bell-shaped curve and our mean is 21.4. So this curve is centered around 21.4. And this is asking what the probability of x less than 15.64. So what this area is under the curve. So when you put this in your calculator, so the lower bound is going to be negative infinity. And then we're going to stop at 15.64. So that's our upper bound. And then our mean is 21.4. And then our standard deviation is 4.8, which is given here. So you put this in your calculator and you get 0.12, which is the correct answer. How high a score must you have in order to be in the top 9%? So here you would do, if I were to draw this out, so here, our mean is 21.4 and I want to know, okay, what score do I need? So it'll be somewhere to the right and the area under the curve is going to be 9%. So what is this question mark value here? So in order to put it into our calculator, we're going to use an inverse norm function, but the calculator works from left to right under the curve. So we need to find this area to the left of that value under the curve. So we can do 1, which is the total area under the curve, minus 0.09 to give us 0.91. So that would be here 0.91. And then 21.4 is our mean and 4.8 is still our standard deviation. So that gives you 27.836. Excuse me. X is a normal random variable with mean 6.6 and standard deviation 2.6. We want to find an A such that the probability that X is greater than A is approximately 0.72. So here we want to find A, and what this is saying is that the probability that X is greater than A equals 0.72. So I always draw a picture. So our mean is 6.6 and we're dealing with a normal random variable. So here is A and our area to the right is 0.72 because the probability that X is greater than A is 0.72. So that's the green shaded region. And now we want to find what is the blue shaded, or what is A. So we need to first find what the blue shaded region is and then use that in our inverse norm function. So 1 minus 0.72 is 0.28. So that's this area here. So we're going to use inverse norm of 0.28 and then 6.6 is our mean. And then 2.6 is our standard deviation. And that gives us 5.085, which is the correct answer. And then our last question, assuming that workers' salaries in your company are uniformly distributed between 20,000 and 60,000 per year, calculate the average salary in your company. So here we have a uniform distribution. So our lower bound is negative 20,000, upper bound is 60,000. So the average would be, what's perfectly centered in between these. So you would just take the average of these two numbers of the 20,000 and 60,000, which gives you 40,000. And that concludes recitation for today. And I hope this was helpful. See you next time.